All right, in this segment we're actually going to be talking about density. And density is defined as the distribution of matter within a certain volume. So based on what we learned last unit, we can kind of rephrase that to say how many atoms are in a certain amount of space. The idea here is that the more atoms we have, the more dense something is. And oftentimes we actually confuse this with weight. We'll say something is heavy or light when really what we're talking about is the density. For instance, if I had two handfuls, one handful of feathers and one handful of lead, I would say, well, the lead's heavier. Well, the reason why is because the lead is actually more dense. There's more atoms in that same amount of space. So how do we measure density? It is calculated by dividing the mass by the volume. And we do need a label with this. It needs to have grams over cubic centimeters for a solid or grams over milliliters for a liquid. We do need to use the appropriate label with the appropriate piece of matter. The formula is this: D equals M divided by V. Now there's also a way that we can write it so that we can actually use or solve for anything that we wish in this formula, because we're not always going to be solving for density. So let me actually get something that will show up here. Here we go. All right, we have something like this. M stands for mass, V for volume, and D for density. So what you do is you basically have that set up. So if I'm solving for mass, for instance, okay, I take mass out of the equation and I multiply my density times my volume. If I'm solving for my volume, I take my mass and divide it by my density. All right. So how do we actually determine density, let's say in the lab? First, you have to measure the mass, and we can do that in the lab. And then we measure the volume, which again, we can do that in the lab, and we will be reviewing how to do this. And then you divide the mass by the volume. Sounds pretty simple. So let's review exactly how we do this. To measure the mass, we have to use a balance, and that's the primary method that we're going to use. You can take the weight and divide by 9.8, but we're not going to worry about that here. I just pointed out because it is one way that you could do it. Now, volume we can measure in three different ways. The first one is the water displacement method for something that is a solid and it has an irregular shape. This is when we put a little bit of water in a graduated cylinder, enough to cover the object. We take that initial volume. Then we lower the object in. The water level will rise. We read the new water level with the graduated cylinder, and then we subtract the two. We can use a math formula, which would be provided to you for a regular shape like a sphere or a cube. You just need to make sure that you take your measurements correctly. And for liquids, you use the graduated cylinder. That's actually the easiest. You just pour it in and measure. Now, since we are measuring both mass and volume, you have to keep in mind your measurement rules. You will need to record things to the correct, make sure you're recording them accurately. You also need to make sure that you're recording them to the appropriate level of precision. In other words, you need to make sure that you have that guess digit there. All right, so let's work a fairly easy example here. An object is measured to have a mass of 10 grams and a volume of 5 cubic centimeters. What is its density? So, if we take a look here, our density formula is D equals M over V. And I plug in what I know. I know the mass, which is 10 grams. My volume is 5 cubic centimeters. When I put that into my calculator, I get 2. Now I do have to take into account sig figs. The bottom one has 1, the top one has 1, so my answer can only have 1 sig fig. So I don't add a 0.0 on here. The other thing I need to add is my unit, and I have grams on top, and cubic centimeters on the bottom, and that is my answer. So now you have a worksheet with 7 different density problems that is homework for tonight.